We may be live, but I will leave nothing to chance this time to make sure that we are actually not only broadcasting, but that we have the broadcasting URL posted to X. And we don't. Okay. Well, we're probably live on LinkedIn, and we're probably live on YouTube. Let me just grab the live URL. Okay, fantastic. I got the live URL. All right, it's working. There's like a 5-second lag here. Let me test this. Maybe more, 10-second lag. All right, there we go. Okay, let's go ahead and kick this thing off. Hello, everyone. Hello, everyone, and welcome to my live stream today, where I'm going to be showing you how to get Vercel's AI SDK running on Golem. So Vercel's AI SDK probably needs no introduction. It is, by far, the #1 most popular library for interacting with AI providers in the TypeScript programming language. It has however many thousands and thousands, tens of thousands of stars, and millions of downloads. So I assume that a lot of TypeScript developers out there are benefiting from its very slick and polished API and its broad support for different providers. And this SDK is actually open source, and it is not tied to any of Vercel's cloud infrastructure. So you can use it in any TypeScript application. Of course, like all of Vercel's excellent high-quality SDKs and open source libraries, it does work great if you're already in their ecosystem, but it is not required. So Golem, on the other hand, is a agent native runtime that currently supports TypeScript and the Rust programming language. And it can natively run agents in a scalable fashion. And Golem's claim to fame is that it's actually built on a new type of technology called transparent durable execution. And what transparent durable execution is it basically means that the agents that are running inside Golem are durable. They have durable state. That means all the stuff that you store in memory is persistent. And that holds even in the presence of failure events. So if an agent is not active and it's put into cold storage, or if a CPU catches fire or something like that happens, then those guarantees don't go away. Golem is actually continuously replicating state information out of your agents, and it knows how to reconstruct those agents when you start using them again, or when there's a recovery after some particular failure event. So all state in Golem, even the in-memory stuff that you wouldn't expect to be durable, is in fact durable. And then the other benefit that Golem provides automatically as part of its agent native runtime is transactional code execution. What does that mean? Well, it means that as your agents are orchestrating complex series of interactions that might span milliseconds or minutes or hours, days, even weeks or months or years, Golem is making sure that every single step, every single line of code, every single call to every model is going to be executed, guaranteed. And within Golem, you have exactly once execution semantics, even in the presence of failures. And outside Golem, you have exactly once execution semantics for all idempotent APIs or any APIs which support idempotency keys. For example, payment processing APIs typically tend to support those. So you get transactional code execution across all of that. What does that mean? Well, agents that are running inside Golem are invincible. They never forget, and they only execute actions or call tools or do stuff in the real world a single time, exactly once interaction semantics. And that turns out to be an essential property of building highly reliable agentic applications. So today, what I'm going to do is show you how to use both of these open source technologies together. So Golem is a runtime for Rust and TypeScript agents. It actually does not have a big SDK, and it's not opinionated about how you build and structure your code. And in particular, it doesn't really have anything to help you do model inference or all the other stuff that you would typically want to do inside the development of some sort of code-based agent. So you need other libraries in order to be successful with Golem. And I've chosen the Vercel AI SDK because I believe it's a great high-quality library. It's already super popular, so I don't need to sell it. I'm just going to show you how to combine these two open source technologies that are quite complementary. Right? The AI SDK does not give you what Golem gives you, and Golem does not give you what the AI SDK gives you. They both provide, I think, a reasonably complete package for building extremely highly reliable agents in TypeScript. So let's go ahead and get started here. I'm going to share my terminal. First, let me just make sure there's no emergencies. Okay, we are live everywhere. Fantastic. And I'm going to pull up Discord. If you have any questions during this session, then your best chance at getting them answered is to hop into our Discord. And I will try to keep an eye on this. And Daniel, please, if you see some poor soul out there asking questions, feel free to interrupt me. Joining me today is Daniel Vygotsky, who is our principal engineer who's leading the development of the open source Golem stack. And as I get stuck on various things related to Golem, Daniel will unblock me. And feel free, if I'm doing something wrong or I'm just doing something in a newbie way, Daniel, please correct me.
I will.
Okay, sounds good. Here we go. I'm going to share my screen. Okay, is this visible?
Yes.
All right, fantastic. So I have, let me just make sure I have not created anything. I wanted to do this from scratch. So I'm just in a Git directory here, which with a bunch of checked out repositories of stuff that I work on from time to time. And what I'm going to do is I already have Golem installed. So this is Golem. Actually, it's not our official last release of Golem 1.4.2 or whatever it is. It is actually the main version of Golem. So this is straight from GitHub, maybe a couple days old, but it is the version I've tested with. So I know this one to work reasonably well. It has some nice features and some nice fixes over the 1.4 version, which is why I'm using it today. What I'm going to do is use this Golem command line application here, create a new application. Here I'm being prompted with application name. So I'm going to call this, let's see, AI SDK Golem. And rather than do Rust, of course, that would be not compatible with Vercel's AI SDK. We're going to do TypeScript, even though I do love Rust, both good languages. And I'm going to choose the simple agent implementing a counter. There's some other stuff that you might want to choose in real life, but I'm familiar with this one, so that's the one I'm going to use. And I need a package name here, so this is just made up. I'm going to choose AI SDK Golem. And I don't need to add another component, so I'm just going to go ahead and continue to create this application. All right. So if everything went well, then I should have, yep, it looks like I have all of my files here that were created from this simple counter template. And I'm going to explain that to you in a second. But before I do, I think I'll just go ahead and create a new repository here and commit all of this. Okay. Forgot the ignore file. All right, so now let's go ahead and take a look at what's inside here. And you can see we've got common TS, which is the directory that common stuff across all of the components of our Golem application might be placed into, as well as some configuration that's specific to the way Golem requires you package up your TypeScript application for deployment. And then we've got components TS, which is where the components of my application, my Golem application, live. And here there's just a single component, and that's that counter agent, which I'll show you in a second. You can see down here, there is a so-called Golem application manifest file. And this just contains some information on what should be included as part of the overall building and deployment. And you can see the common stuff is included and all the component stuff is included. And then we've got two different environments here, local and cloud. This is our hosted version. This is the one we'll be using today, which is just local with the local server. And then this actually is a new addition. And obviously we want to make Golem very well suited for agentic coding. So the goal here is just to prepare your coding agent for knowledge on how to interact with Golem, how to do basic deployment and testing, etc. That comes as part of this template. We don't have to do anything else to get that. And then inside source, we're going to find our simple counter agent. Let's take a look at that. We've got this agent decorator here. And this is actually a new feature here. I'll explain that in a second. But let me just go into the name of my agent, which is counter agent. It extends base agent. It has this constructor, and it has a single, what we would term an agent method. So agent methods are basically the API of your agent. Public methods like this are the public API of your agent. The agent constructor here is doing a very important purpose. It has a very important role. And that is in Golem, every agent is uniquely identified by its constructor parameters. So Golem is designed to scale horizontally. You can deploy it in Kubernetes or whatever you want, scale it horizontally. And so you can have millions of agents, et cetera. And it becomes important, especially in like agent-to-agent communication use cases, for you to be able to address a specific agent and say, I want to talk to that one. I want to call the public API of this specific agent. So how Golem thinks about agent identity is constructor parameters. You can really use any constructor parameters you want, as long as they're pure data. Golem doesn't care. For purposes of a counter agent, sort of what you would think about as counter identity would just be a string. It's just a name of the counter agent. And here we have a single agent method called increment. We have some state associated with this counter agent, which is just a number that is initially set to 0. And then the increment method both increments the counter value by 1, as well as returns the latest value. So I said I would explain this mount in the endpoint here. So Golem has this latest pre-release version of Golem has a very easy way for you to take the agent and make its methods public as part of some REST API. This is super easy. It's all code first. It's all pipe safe. You can generate open API from this. It's really nice. And how you do that is you just sort of add this mount. You mount this particular agent at a base URL. And here we're mounting this at counters slash a name here, where this name is coming from this constructor parameter. All of this is type safe. If you try to do something that is not going to work, then you're going to hear about that when you go to build this. And then this increment method is mounted at the following endpoint, which is relative to the base URL here of the mount point. So basically you can see if you were to do like a post to /counters/counter name/increment, then that would end up incrementing the counter of the specified name by 1, as well as returning in the JSON body the number here. So that's how this works. I'm not going to go into that feature today. That's not the purpose of this. But just to say, if you build a cool agent and you want to slap a REST API on top of it in a few minutes, then all you have to use is these decorator options, and that API will be made available. And be nice, Jason, interact the way you would expect. All of the previous stuff, those of you who have followed Golem for some time will note a huge simplification in how this is done. We used to require you do this in the YAML file by using rib snippets, so you had to learn rib, the rib scripting language. All that's gone. Now you can define these endpoints in your source code file. All right, so what I am going to do here is I am going to actually get the Golem server started. And I'm going to make sure I do that with the -- clean, just to clean up any junk that might be there. And the server is running now. And what do I want to do? I think I want to, let's see, I'm going to go into this components TS directory, into here. And this is the TypeScript component with the counter that we're looking at over here. Oops. And so I want to actually just show you these steps one by one. Later, you'll see faster ways of doing this. But for now, I'm just going to deploy this. Golem deploy, which will automatically...
John, we are still seeing the NeoVim only.
Oh, 1 second here. I am still in the same terminal window. Let me fix this. All right, thanks for that heads up. Let's just try this. I think maybe the problem was that every time I create a new window in here, you're not allowed to see it. I'm going to switch back and forth between these tabs. Can you see them?
I can see the first one now selected.
You can't see the other ones?
I can see the tabs, but if you click on them, nothing changes.
All right. Well, first major malfunction of the live stream. It's not unexpected. What does that mean? Well, it probably means, let's just see if there's another way for me to share this. It's going to result in you seeing everything. Good thing you said something. I was not going to do most of my coding on those screens here.
Yeah, I wanted everybody to see the deployment. You cannot hide that. So nice and colorful.
It is nice. All right. Maybe I'll try this one.
Now it's very low resolution and big font. Now it's not. So now I see the deploy tab. Can you try to switch tabs? Yeah, now it follows it.
Hooray. Okay. Fantastic. Right. So there we are. Deploy, and Golem deploy does a little planning process. It shows you what's going to be changed before it does it. I do want to continue the deployment. We need to register this domain. Yes, yes, yes. And there we have it. It should be deployed now. There were no errors. Golem does build it as part of the deployment. So we don't have to worry about that. Let me go ahead and test this using the Golem REPL. Okay. So you can see that my available client types, agents, or counter agent, and it has a single method here called increment. Let me go ahead and show you how you connect to a agent that's running inside Golem. You do that, at least in TypeScript, using this syntax, counter agent .get. And the name of my counter is going to be, what is called impressions. And then I'm going to do agent.increment. There's only a single method that I can call on this, and you can see I get back 1. I'm going to increment it a few times, 2, 3, 4, 5. Okay, fantastic. So that's working. And you can see here that this syntax, it's actually going to match the exact same syntax that I would use if in my code base, let's go back to my code. In my code base, if I were talking to another counter agent from another agent. So actually, let me just show you this. It's not super realistic, but I could just say something like let agent equals agent, counter agent get impressions, and then I could go ahead and call agent increment. So I could do that. I don't need to. That's not a very realistic example, just to point out that the syntax is exactly the same with the REPL. So let's go back to the REPL. And what I want to demonstrate first is I'm going to exit this REPL, and I am going to actually kill the server. Kill the server. I'm going to run it again. It's running again, and now I'm going to start up the REPL. I'm going to grab a handle to that agent. Golem has upsert semantics, which means if you try to connect to an agent that does not exist, then it will be automatically created the first time you interact with it. So no matter what, this would succeed, even if I had not previously created this agent. Let me just call increment again. And you can see the number here is now 6. It's 6 despite the fact that obviously, because I killed the server, right, there's nothing in memory. So agents are always there. Assuming the server or the Golem cluster is running, agents are always there. You can always talk to them. Even if they're pushed out of main memory, when you talk to them again, they're just sort of brought back in and they resume exactly where they left off with all state intact at the exact line of code wherever the interruption or failure event occurred. So Golem agents are durable. They are durable by default. Let me go ahead and show you this agent by using a command called agent list. There's autocomplete in this REPL. Actually, it's called list agent. List agents, I think. No, it's called agent list. There we go. So it's called agent list. And what this one does is just show me all the agents that are currently running, as well as their revision number and whether or not they're doing any active work right now. And here I can see there's a single agent, which is the one that I created by trying to interact with it. And there's 0 pending invocations, which just means it's not doing interactive work. There's a single component revision because I've only built the component once. And you can see the component name that I originally specified when I created this using the Golem new command, as well as the time in which it was created. So I don't think there's anything else to see here. Nothing else of interest. So let me go ahead and exit. And I think what I want to do now is talk about, or rather not talk about, but let's just go ahead and integrate the Vercel AI SDK in here and get a basic hello world working using the AI SDK. So in order to do that, we're going to make a number of changes. We obviously have to npm install the AI SDK, and then we have to add some imports and some basic scaffolding around that and integrate it into Golem. Rather than do that by hand, I am actually going to have my coding agent do that. But before I do that, I am going to cheat just a little bit in the sense that I am going to teach my coding agent about the Vercel AI SDK with an agents.md file. Now, this is not actually going to affect your success. If you don't have this, you're still going to succeed. It's just going to take longer because your coding agent is going to have to figure out more stuff. It's going to have to grab docs and or poke around in the source code, etc. So I don't want to have to spend any time doing that. So I have in the background, you can't see it, but I just cheated and I copied a pre-existing agents.md that talks about the Vercel SDK into this directory. And actually you can see it here. Oh, no, you can see it here. Yeah, you can see it here. And this is a new file. So here's what I want to do, I think. I am going to go ahead and split this terminal. And on the right-hand side, I'm going to open up LazyGit. And you just see that new file there. And what else? I am going to start open code in the left-hand side. And I'm going to make it look at our component, our TypeScript component. And I'll just ask open code to go ahead and familiarize itself with the project structure. So it's currently exploring everything. I'm using Claude Sonnet 4.6, which is probably fine for this. This is not rocket science. And while it's waiting, let's see, I'll just go ahead and maybe review some of the Golem commands, which come straight from agents.md. We've got server run, which you've already seen. We've got deploy and deploy -- reset, which is quite useful. One of the common hangups or difficulties that people encounter when using Golem, including myself, is agents always live. They live forever. They're immortal. So you go and you make some changes to your code, and then you go back to the REPL, and then you try to test something, and you don't see any changes. Why? Because you're really interacting with the old version of that agent. So concurrent agents can exist with any number of different versions. So you can have agents that are from the state of your code a year ago still running concurrently with agents that are using a more recent version of your code. So obviously that's ideal when you're in production and you don't necessarily want to update all the agents out there to the latest version of your code because you don't know if that would work or if that's what you want. But it's not ideal when testing. And so you can just go ahead and blow stuff away when you're doing a deployment with a -- reset. It's quite handy. For testing agents, we've got the REPL, which I've already shown you. And then you can actually invoke a specific agent method. I'm not going to talk about that. I didn't really like that one myself. You can delete agents. You can also update agents. There's a whole host of things that you can do. Let's go back and take a look at this. It looks like open code has successfully deciphered the structure of the project. And it understands it well enough to get started. So what I want to do first is merely introduce the Vercel AI SDK in a hello world type fashion, just the simplest possible thing that could actually work. So I'm going to tell my agent to do that. So I'm going to say install the Vercel AI SDK and modify the counter example to be the simplest possible hello world type example on Golem using this SDK on Golem. So we'll just see what it does. You can keep an eye on its development, obviously here. It's produced a to-do list, which is installing Vercel AI SDK. It's got to rewrite the counter agent, and then it's got to update this to add an open AI API key, which is actually correct. Obviously, if we're going to use the AI SDK, then we need to get an API key from somewhere for testing. And then we've got to build the component to verify it compiles. And then even beyond that, we obviously have to test that. But that's okay if we have to do it ourselves. All right, so it's encountered a little bit of difficulty, but it's finding its way around that. Let's go ahead and take a look at here. We don't need to move here. You can see here. all the changes that it's done. Basically everything that it said it was going to do. Looks like it's done. Let's just go ahead and take a look at that main TS file and see how that has changed. And you can see here, it's dramatically simplified things, right? It's gotten rid of a lot of these decorators that were just showing off the features of Golem that come from the template. We don't need any of them. The only one we really need is the agent decorator. And that's what triggers the sort of introspection of this and capturing all of the metadata so we can do all of the type-safe API stuff. So here we can see there's a single agent method called query, which has a user message. And what it does inside there is it creates an open AI instance using the API key, which is actually coming from Golem YAML. So if you look in here, there's an API key that is being pulled in from my system environment variable. That's my system environment variable. And that's being packaged up into this application. So that's where that's coming from. And it's available on process env. And then we call what is perhaps the simplest function in the AI SDK, AI function, which is generate text. We specify which model we want to use. We give it a system prompt. And then we also provide the user message. And then we return that text. So hello world. This is hello world in AI SDK running on Golem. But we actually haven't shown that it's running on Golem just yet. So let's do that now. Let's restart the REPL. And now we can see there's a hello agent with a single method called query, which takes...
I'm not sure that your agent deployed it, actually. We should check.
All right, let's do that.
You can do it from the REPL as well, but anyway.
All right, you're correct. Yes, so it did not. So I'm just going to tell my agent to deploy it. Obviously, that's very simple, but I just wanted you to see that agents can figure this stuff out. Well, it's figuring it out.
Oh, yeah, it's actually right, because we no longer have an HTTP API associated with our agent, so it had to remove something from the YAML.
Fantastic. So that's good. So now it's, in theory, deployed successfully. Just go ahead and restart REPL. Hello agent query. Okay. And let's create a test agent. And let's have a single method. Takes a string. And I don't know if you can see that. That's kind of getting in the way there. Move it over to that side. I'm just a program, but I'm here and ready to help you. How can I assist you today? All right, so we've got a basic agent working with OpenAI. And what I'm going to do is right now I'm going to ask it, what did I just ask you? And we get this error message, which is, I'm unable to recall previous interactions. So I can't see what you just asked. However, feel free to ask your question again, and I'll do my best to help you. Okay, so I asked this agent 2 questions, and it has no memory or knowledge of the first question that I asked it. And I've just said, Golem lets you build invincible agents that never forget and only do things once, right? So what am I talking about here? Well, this comes back to how I have structured this agent in the code. And in this code here, you can see that every time I am calling generate agent, generate text fresh, and the AI SDK many of the TypeScript SDKs out there for AI, does not actually accumulate state in memory. Rather, it relies on you to manage state. That way you can decide, what you want that state to be and where you want to persist it, etc. So that is not being done here, which means every time you call generate text, it is, in essence, a clean slate. It only comes with this system prompt here and the user question. And that's true despite the fact that Golem is durable and gives you durable state. We're just not really taking advantage of durable state. So let's fix that. That's the first thing that we'll fix. And how I will fix that is I'm going to tell my agent to modify the hello agent in the following ways. First off, let's just rename it from hello agent to Golem agent, or no, chat agent. Let's also collect conversation history in memory. And then we're going to do rebuild and redeploy. Let's see if that's enough of a hint. And let's keep an eye on what it's doing. We've got, it looks like a history of model messages. You can see that there. And this history of model message. And then you can see this history is being used. We're pushing on response messages. We're also pushing on the user's message for the role of user. So we're keeping track of the full conversation now. And let me switch to the editor. It looks nicer here. It's got syntax highlighting, which looks good to me. Let me just go back and see if this is done. It does appear to be done. I'm going to ask I'm going to ask my coding agent to test it and just see if it can do that. All right, perfect. So what my coding agent did is it did two turns. First turn was my name is Alice, and then the AI responds with nice to meet you, Alice. How can I assist you today? And then the next question is what is my name? And then of course, if the agent is remembering conversation, it needs to say your name is Alice, which it does. So we know that this is working. Let me just walk you through why it's working. So this is an array of model messages that is stored in memory. And every single time we call generate text, we're feeding in the history. So this history becomes part of the conversation context that's fed into the model. And this new message is always appended to the end. So we're expecting the agent to come back with an answer. And those answers, whatever they might be, are then pushed onto the history. So what we've done here is we've gone from an agent that has no recollection of either prior questions or prior responses to an agent that now can remember all of the questions that we asked and all of the responses that it provided in history. So we've gone from a fairly dumb sort of one-shot agent to a much more sophisticated one that can have intelligent conversations and keep track of context. Now, despite the fact that this looks really simple and naive, and obviously not production grade, it is in fact production grade. Why does it look not production grade? Well, obviously we're storing this stuff in memory. And as we all know, stuff that is stored in memory is volatile. It goes away and it's not going to be there. And obviously many different things could happen. The agent could crash. We could restart the server. Let me just show you that. I don't even need to show you that because already in the time span that we've been talking, I think it only takes about 10 seconds, right, Daniel, for an agent to be flushed, more or less?
Yeah. Well, it's only flushed if there isn't enough memory. So there is a cache set of agents. So probably it's not flushed actually.
Okay. Well, then let's just
but if
go
there will be
ahead.
many agents, then yes, after being idle for 10 seconds or something,
Yes.
then it's going to be removed from memory.
Let's just go ahead and kill our server. kill it dead, and we're going to run it again. And now we're going to go back to the REPL. Oops. I don't know how this is going to work. No doubt David would tell me to just trust it. It's going to work anyway, but I'm going to do a little paranoia-based development here and restart the REPL. And I'm going to get this. Whoa, right. I renamed it chat agent. That makes sense. And then I'm going to say, how are you? Whoa. What did this change to? Changed to chat. How are you? Oh, what did it use, right? That's the one thing I need to test, which is it's chatting with an agent named Alice.
You can also
that's
ask how many messages were asked before, like you did last time. That's
yes, but I killed the
interesting.
server. So let's see. Alice is equal to chat agent. Get Alice. And Alice dot chat. What was our prior conversation? How about that? Okay. So in our prior conversation, you mentioned your name is Alice. How can I assist you further? All right, fantastic. Success. What did I just show? I just showed that despite the fact that I killed the server abruptly and restarted it, our agent called Alice, which was actually created by our coding agent, still exists and still has all of her memories intact. So agents in Golem are durable. And despite the fact that we just stored this stuff in memory and we're not using a database, Golem gives us the same guarantees on everything that we store in memory as we would have in a database. So this allows us to program simply. We don't need persistence. We just write ordinary code, and Golem makes sure that the state is durable. And then when these agents are actually running, that execution of the agent is transactional. And again, I think CPU catches fire or whatever, that's not going to stop these agents from continuing their mission and only doing their work once. Why? Because Golem supervises and detects failure events. It recovers agents with their prior state intact. And because it's continuously sort of snapshotting the state of all these agents, it actually is incremental, so it doesn't actually cost a lot. It's minimal runtime overhead. It's able to restore agents with their state intact at the very line of code or at the even sub-expression where they left off. So from my perspective as a developer of an agentic application, I don't have to worry about failures anymore. Failures don't happen. Infrastructure failures are a thing of the past. And interacting with databases, well, I can do that if I want to, but I don't have to. I can just store stuff in memory. And that's the benefits that Golem brings to the table, which are invincible agents that have durable state and transactional code execution. And I don't need anything. I'm not using any sort of SDK. I'm not using persistence. I'm not using a string called use workflow or use step or whatever, like you might do if you were using the workflow SDK that Vercel developed, which is also amazing quality. And I highly recommend it. I highly recommend Golem even more, though, because it's better. It works well with the AI SDK. So here we have our first invincible durable agent. You can't kill it, which is going to frustrate you during development. So just remember -- reset, or you can always delete agents one-off if you need to. All right, this is a very simple agent, and it doesn't really do anything interesting. So I think one of the most fundamental things that the AI SDK brings to the table is the ability to introduce tools into the agents that you build. And tools are basically snippets of code that you provide that the AI can invoke. And that makes agents really interesting. This agent here, it's a good therapist maybe, but it can't actually do anything in the real world. So if you want agents that automate repetitive work, if you want agents that do stuff in the real world, then you're going to have to add tools. and that's natively supported, and it's quite nicely developed in the AI SDK. So what we're going to do is add a very simple tool. And last time I did this, I added a dice rolling tool. I think that makes sense to start with. Very simple sort of tool. And what we're going to say here is this dice rolling tool is going to be able to roll a dice and get back the number. You'll specify maybe how many dice do you want to roll, and how many sides are on the dice, or something like that. Maybe we'll make it even simpler. And we'll bundle that up in a bit of TypeScript code. And that TypeScript code is going to generate a random number, and it's going to feed back the result. But what we're going to do is take this TypeScript code, and we're going to make it accessible to the AI. So the AI, anytime it needs to roll some dice and get a random number, it's going to know it can actually call into our code and get the random number that way. And this is going to open up the door to making agents that actually do stuff, which of course is the key to making agents useful. So let's just sketch this out. We'll just see what we get back using this prompt. There's a few things that are going to change about our code, and you'll see them over on the right-hand side in lazy get, probably. Yes. Okay. Let me just take a look at that. So here we have a local roll dice tool, which is constructed using this tool constructor that comes in from the AI SDK. So this is a function here that comes from the AI SDK that we're using down here to construct the tool. And we provide it with the following object, which has description. This description is actually important because the AI is going to know whether or not to use this tool based on its description, and also potentially based on the input schema, but primarily based on the description. And then the input schema describes the structure of information that is required by this tool. So in our case, we're going to require two pieces of information in order to execute the tool. The first one is the number of dice to roll, probably one, but maybe two, maybe three. And the second piece of information is the number of sides that each die have on them. Probably 6, but it could be any number. And when you define a tool, you specify not only its description and its input schema, but you also specify a way to execute that tool. And here we're executing with this function, and we're going to use the math random number generator, multiply it by size, add 1, math 4, etc., all the math stuff here. And we're going to return this, the rolls here, which will be an array that contains the results from each die roll, as well as the total, the summed up total of all the faces on the die. Okay, so how do you make this tool available to the AI using the SDK? You specify a new property here in the object you pass to generate text called tools. And the field names are the names of the tools. So this tool here is named roll dice, and that's its description. That's what it expects as input. That's how to actually execute it. And then what happens is a sort of sophisticated back and forth whereby the agent will decide to use a tool, and it will therefore say, I am choosing to use this tool, and here's the input I want to provide to it. It knows what the structure of that input is because it has this input schema. And then what happens is the AI SDK says, oh, I need to invoke this particular tool, and I already have the inputs of the tool. So I'm going to grab those inputs and I'm going to call this function. And then after the AI SDK calls this function, it's going to grab the output as JSON, and it's going to tell the AI by appending another message onto the message history that the tool execution resulted in the following output. And this will be the JSON object that the AI now has access to. It can see that in the context, the conversation history, and so it can provide whatever sort of response is necessary to the user to complete the task. So let's show this in action. And how we'll do that is, I'm not sure if we have to restart this. Do you know, Daniel? Am I going to have to restart this or not?
I think you don't have to restart it. Let's
try it. I'll say roll a single die for me, six-sided. I rolled a six-sided die and got a 3. All right, well, let's verify that our tool is being called by going through agent oplog, which is basically the history of our agent. Everything it's ever done in its life is stored in the oplog. Oops.
It's the correct command, but it doesn't know which agent you mean, and unfortunately you cannot just pass Alice right now. You have to construct this whole agent ID, which you can copy paste from the agent list. It's probably easier.
You're right.
You just first run the agent list without any parameter, and copy the agent name and then use agent upload with that. This is going to be nicer in the final version.
Yes.
So yeah.
All right.
Are you looking for a random call or something?
Yes.
It's a bit hard to find. I would actually put some logging into the tool itself.
Sure. Why not?
But yeah, there should be a random call somewhere.
Let's go ahead and add logging using console log.
That's a
So we
longer
can-
prompt than adding a console log line to the tool. Or maybe not.
Okay. And it is already building and deploying. It's sort of gotten used to the pattern here. Let's wait for that to finish. And then I'll go back to the REPL and I'll verify that. Is it done? Yes. Okay, it looks like it's already testing as well.
Oh.
Okay, perfect. So let's do this again. Now I can see the logging. Yeah, so now let me just show you where it added those lines. It added them directly inside this method here. So we've got rolling, whatever, and then we've got the result down here. And in the REPL, you can see rolling, one dice, one die, six-sided, and we've got the result back 3. So we've not only confirmed our tool is working here, it's actually being invoked. The AI is not lying about that. But we've also proven that the AI is using the result of that tool and displaying that to the user because those results match. Okay, fantastic. Now, what else? Well, there is one thing here that I don't really love, which will definitely be fixing up at some point in future Golem releases. It's the fact that we have to specify the input schema here. But the interesting thing about Golem is that it already knows what the input schema is and the output schema for all of your agent methods, as well as the constructor. And the reason for that is, of course, this decorator here, this agent decorator here, which is how we learn about the structure of this agent so that we can make that API. And so you can use it in the REPL. So you can call it, right? So if I want to do agent to agent, then it's going to be taking advantage of its knowledge of the structure of these types in order to create a type-safe API that we can invoke. And in fact, I think that's a great feature we can add to our little chat agent is the ability for one chat agent to talk to another. But before we do that, maybe I'll add one more feature here, which would be maintaining an internal to-do list. Like one of the things we can have our chat agent do is be more like a personal assistant and remember things that we tell it. And how we could do that is we could just have a little bit of state here that stores a bunch of to-dos. And then we could add enough tools that are capable of manipulating these to-dos. So that would involve adding a new to-do, also marking a to-do as completed, and then deleting a to-do. So let's add the to-do functionality. And then after we add that, we'll go ahead and add our final feature, which will demonstrate Golem's ability to do type-safe agent-to-agent communication. And we'll wrap that up in a tool. So now our agents can talk to each other if they decide that's necessary in order to solve some problem. So let me do that here. I'm going to say, let's add a new piece of state, an array of to-dos, each of which has a description, an ID, and a completed status. Then we'll add, I think, 4 tools are sufficient. We want list the to-dos, add a new to-do, and delete a to-do by ID, mark it to as completed. Or not, I suppose. So those are the changes we want. And here's the data structure that our coding agent generated as ID, description, and completed. That's correct. We have a list to-dos tool, an add to-do tool, a delete to-do tool, and a set to-do completed tool. So all of these tools, plus our original dice rolling tool appear here. And then at the bottom, we supply yet more tools to our AI. Go ahead and see where our agent is in testing this process. Okay, they're done and implemented correctly, or at least the agent thinks so. That's no guarantee. Let's test it ourselves. Actually, I want to see if it's still testing using Alice.
Yeah,
Yeah,
I can see that.
Okay. All right, fantastic. So I'm going to say, what are my to-dos? Okay, my current to-dos are write tests and deploy to production. Writing tests is already completed. Deploying to production is not completed. So let me just ask it to mark my deploy to prod to do as completed. And we can see the logging from console log there. Let me just see what my to-dos are. Yeah, they are both completed now.
Could you also add some agent methods to show how we can combine these two worlds, the chat interface with the real typed interface, that we can get the to-dos and add the to-dos just directly by invoking through Golem?
Oh, yeah, right. That's great. Okay. So what Daniel is asking is, right now, I'm not really using Golem's agent methods. I have a single agent method here. From Golem's perspective, this is a single agent method, which is fine for pure AI use cases, but I actually might want to use this agent from other agents writing code. And it would be awkward to do that right now. I would be forced to go through the chat interface. So I really wouldn't consider this best practice. This is not best practice. It's not the way we're carroting people to build their agents in Golem. Certainly in the future, when we sort of have automatic tools for any of these agent methods. So what we need to do in order to be able to programmatically access all of this functionality that we just added is expose these different tools as methods on our chat agent. So that should be relatively straightforward refactoring. We will have public methods on chat agent to do what each of the tools do. And then we'll do delegation. We won't replicate that functionality. Just for AI SDKs tools, we'll just delegate to the public methods. So let's give it a second to think about this. And when this refactoring is complete, we're going to expect that we have async roll dice, async list to-dos, all living at the top level inside this chat agent. And in fact, that's what we see here is roll dice, list to-dos, add to-do, delete to-do, set to-do completed, and then chat. So this just becomes a simple wrapper over that. Maybe not super simple because we've got to deal with all these schemas and descriptions, but there's no way around that for now. Stay tuned to Golem 1.5 for a fix to that. Okay, so let's just make sure nothing broke in this refactoring. Okay, nothing broke. However, we've not altered the state, right? We've not really altered the state of our agent. So we can probably just update it if it's still there. Let me see if it blew it away.
Yeah, maybe. Yeah, we can try. I'm not sure. But the worst case, we can just...
Oh, it blew it away.
Oh, it's already gone. Oh.
Okay, well, let me... I'll just actually... This is fine. I'll just go ahead and create a new agent. Oops. All right. I'm going to exit this REPL, restart it. And now you can see something different. So we still got our chat agent here, but there's more than just a chat method on it. We actually have add to do, delete to do, list to do's, roll dice, and set to do completed. So what this allows me to do is I now have a way that AI can use all of the methods of this agent to do specific things, but also I can programmatically interact with this. So that way, if I, as a developer, know that I need to use all of these tools in a specific way as part of bundling up in a higher level tool or other AI agent, I can go ahead and do that. And I don't have to leave that to chance. If you do have a certain workflow, if you know that things need to be done in certain ways, in certain parts of your agents, you shouldn't let the AI have any choice about that. It's going to be slower, it's going to cost you money, and it's not going to be deterministic. So always in building high quality agentic applications, you want to remove as many sources of indeterminism as you possibly can, which means if you can write something using code, you do that. So here I can actually use all of these methods as code, and also the AI can call them, right? And that's where Golem 1.5's improvements are going to come into play, basically when you can just automatically use any of these agent methods as tools. And we've done that now just by wrapping the agent methods as tools, but that's the direction of Golem. We're aware that there are these two different ways to use all of these tools. One is by you calling them in a type-safe way, and one is by your agent calling them with access to the input and output schemas and descriptions and all that. And they're both useful for building high-quality, very reliable agentic applications. So let me just do a few things here. I'm going to call agent.add to do. And I guess this would be the to-do description. Write tests and fix tests, run tests, deploy to prod. And then I'll just list the to-dos using this other method. I do get autocomplete here. So I have those to-dos, which are the 4 I added. And then I'll roll dice. Right. I need to supply 2 arguments of type numbers. So I'll do, I can't remember if it's 1, 6, 6, 1. I guess it would be 6, 1. Nope. 1, 6. Okay, yes. Perfect. So here I can interact with, it would be great if we can find a way to improve that at some point in the future. You can see I can interact with these agents programmatically, and also AI can interact with these agents, right? These agents can just be a medium or a unit of programming in a distributed system. And I don't have to use AI, LLMs, if I don't want to, but obviously it's there and it's easy and it fits into all the features that Golem bundles into this. Okay, so now we have an agent that is capable of doing all of these things, and we can also programmatically interact with it. What I would like to do now is, for our final feature, I want to add the ability to have one agent delegate to another agent. So we have, let's imagine all of these agents as personal assistants. In fact, let's go ahead and maybe what we'll do is we'll just go all in on that idea. And we'll say that chat agent is really a personal assistant. And this is the nickname of the human, right? So we'll imagine that there's a single personal assistant agent for everyone, and that's identified by the nickname of the human. That's what we'll do for this demo. So let me just do some refactorings. We want to rename chat agent to personal assistant. Rename the constructor parameter to username. And that's actually the name of the user who is served by that personal assistant agent. And then I'm trying to think if there's anything else. Instead of chat, I'll just have like, I'll call this request. That fits better. Okay, so it's working on this. So what I want is now we'll imagine every single person has their own personal assistant. and that agent is identified by people's nicknames. So I have a personal assistant agent, but so does Daniel. And one of the things we can demonstrate with agent to agent is that my agent, my personal assistant agent, can talk to his personal assistant agent and maybe make changes on his calendar. Maybe our agents can coordinate. And this agent is saying, hey, John wants to meet. What's your schedule look like for the next week? And then Daniel's agent get back to mine and says, well, here's what it looks like. And then my agent says, how about this time? And then his agent says, no, that's not going to work. Daniel never likes to do. He has the gym. It's not on his
I,
calendar, but
I
he
think
goes to
you
the
just
gym.
want to push more to-dos to me. That's all. But
Hey, it's the gym. You shouldn't mind that.
okay.
That's not a to do, right? Okay, so we're already done here with the refactoring, which is fantastic. This should not have changed anything except the names. Okay, it went ahead and blew everything away, so that's fine. Give me to personal assistants, assistant agents, one for John, one for Daniel, with test data. So I can play around in the REPL. So what I'm asking the coding agent to do here is just to add two agents with some test data. And while this is, go ahead and ask it to test this. While I am having this test this, I'm going to take a quick bio break, and I will return momentarily. All right, I am back, and supposedly both agents are working correctly and independently. Let me just go ahead and play around with this for a second. So we have two personal assistant agents, one for me, one for Daniel. Note there's a case difference here between your TypeScript code and the agent name here. That will be gone in 1.5. It's just one of those minor details we're taking care of. Request. What are my to-dos? Okay. And same thing, we'll ask Daniel, what are my to-dos? Okay, fantastic. So all of that is working. So now we're in a good position to add our final feature, which is going to demonstrate agent-to-agent type-safe agent-to-agent communication in Golem. And this is going to be a new tool that delegates a request to another agent. We'll add a new tool that follows the existing conventions and personal agent that delegates a given request to another personal assistant, returning the response. And I'm just going to add a hint here. I don't think I need to use personal assistant yet. Other assistant request. So this is just the same stuff we would use from the REPL, right? Same syntax, same everything. It's all type safe. Let's see if we have luck with this little prompt. Let's take a look at what it's thinking about here. We've got a new function here. That's called delegate to, and it delegates this request to the specified agent. So it gets back the other agent, the other personal assistant for the specified username, and it just calls await other.request. And this request here is the same method down here, right? So this is the beauty of Golem's type-safe agent-to-agent communication, is that the public methods on your agent you can utilize in type-safe RPC. This works out of the box. It has guaranteed reliability with exactly once execution semantics. So it's always going to succeed. There's no failure. Actually, I get back a string here. And the reason why I get back a string is because there's no way that this agent can fail to talk to that agent, other than that agent being failed. That's the only way, which is considered a catastrophic failure. But in the ordinary course of operation, there's no reason it can fail for sure for any network error or any CPU error or any sort of transient failure. Doesn't matter what's going on at the level of infrastructure or network, this call will succeed. The only question is latency. On the happy path, everything's up, everything's running, the CPU is not on fire, there's no network problems, it's going to succeed right away. In the unhappy path, it might be a while, but I don't see such things from my code. I don't have to think about failure scenarios, which is great work. It's great news, fantastic news, actually, if you are using coding agents to build on top of Golem. Why? Because coding agents are not very good about thinking through all these error scenarios in a complex distributed system. And in Golem, you don't have to think through any of those failure scenarios because they simply can't occur. I don't have to think about persistence. I don't have to think about network failures, CPU failures, all of these massive categories of errors that are so complicated and lead you down the path of building event source systems with Apache, Kafka, and finite state machines and all this other machinery. It just goes out the window. It's just very simple code written in TypeScript or Rust or any other language that Golem supports. And Golem being that reliable sort of agent-first runtime with durable state and transactional code execution makes this code so simple and so elegant that even a relatively dumb coding agent can build quite sophisticated production-grade applications on top of Golem. All right, so let me just make sure that the tool is here. Okay, I see the tool. Delegate a request to another personal assistant by username and return their message. All right. Well, now for the test. Unfortunately, I suspect that everything was blown away. Let me just verify that. Well, sorry, Daniel, you were blown away. Your agent was blown away. Mine is still there. Oh,
It's
wait.
not a surprise that your coding agent prefers you and not me.
Oh, Daniel's
And then
agent doesn't
it's
exist. Look.
I'm sure you've put some instructions to your hidden agent MD about
No,
this.
no special casing. No Daniel special casing. I bet what it
Yeah.
did is it blew away both of them and then discovered it needed to recreate mine. Yeah, look, it's just sort of
Mhm.
automatically gotten in the habit of resetting, which is nice, I think, in general, but it's not nice in our specific case. It's noticing, yes, it's noticing that there's some sort of a hang.
That's suspicious.
One thing I noticed is that this time, doing this little exercise, delegate to is not smart enough to check that you're not delegating to yourself. Because
Mm.
if the agent would be delegating to itself, then this call here would block forever. And that's because within
I
the
think that is actually supposed to give you a meaningful error
a
about you're
failure.
not allowed to call yourself.
All right.
I remember we have a test case for that, but maybe it's currently broken. I don't
Well,
know.
I'm not seeing anything. Oh, there we go. There's some failures. Okay. I'm going to add this to your to-do, Daniel. Investigate this.
That's not that error. It's another thing.
It's not that one.
No, it's just trying to connect to get the log stream from that agent, and it doesn't exist at all.
All right. Well, let me take a look and see what's going on. I am going to, because I don't know what's going on here and I don't have time to debug it, I am just going to do what I know is going to work and I'm going to blow everything away.
Yeah, let's try it out by hand, I think. Because it's doing things so fast that we cannot see what's happening.
It's going to work this time.
Too late.
It's too late. I can't keep up with it.
Okay, now it seems to be working. I responded something.
Okay, fantastic. So let me just see it for myself. Create my two agents. And I'll say, I will say, ask Daniel's personal assistant to add a new to-do to investigate the live stream demo. Okay, so delegate to Daniel. In response from Daniel is the new to-do investigate the live stream demo issue has been successfully added. Let's just go ahead and confirm that by talking to Daniel's personal assistant, saying, what are my to-dos? And yeah, so there's a new to-do at the end of your list, Daniel. Investigate the live stream demo issue. So that was actually created by my agent talking to his, and his go ahead and figuring out which tools it needed to do, and then using them, and then getting back to mine with the result. So as you can see, this feature called agent-to-agent communication in Golem, it's very, very, very powerful and lets you create sort of agent swarms and all sorts of other patterns where agents are coordinating together to accomplish specific tasks, all with the benefits of type safety and programmability. I as a programmer can go in here and talk to all these agents in a type-safe fashion as well. It's not just sort of opaque blobs communicating through strings. There's actually a programmatic interface, which is fantastic. And it's also good for when you're having agents, coding agents, generate code for Golem. Those types help you a lot. Types in general help with coding agents because they help correct them and help keep them on the happy path. And we have all of that baked into Golem thanks to its type-safe RPC, supported in both Rust and in TypeScript. So there we have it. We have some pretty interesting agents developed over the course of an hour and a half that are running on Vercel's fantastic AI SDK. No issues. We had 0 issues with the AI SDK. We managed to implement durable state just by storing things in memory. And then we obviously have transactional code execution, so we don't have to worry about our agent failing midway between some process due to application restart or anything like that. It doesn't matter what happens at the level of the infrastructure or servers. Our agents are going to continue all the way through to completion, and nothing can stop them. They become invincible. And all of this stuff that we're storing in memory is as reliable as it would be if we stored it in a database, only we don't have to store it in a database. And Golem will try to keep that stuff in memory, but when you have too many agents, it's going to take the ones that aren't being used anymore, and it's just going to put them in cold storage. So if you want to think about like the way you interact with coding agents, right? You have all these different conversations or projects or tasks or specs or whatever, depending on your favorite coding agent. And those things, you're only working on a few of them at the same time. Those are the ones that should be in memory. The rest should not. And Golem does that. It's all baked in. We don't have to worry about rolling things out of memory and putting them in cold storage because Golem handles that for us. And then we have all of the other benefits around type-safe RPC and just getting out of our way. The best thing about Golem is that it just stays out of your way. It becomes invisible, lets you write ordinary code. It's very simple and just acquires all of these superpowers for free because Golem is not an SDK. It's not a library. It's not a framework. Golem is a runtime. Golem is the agent native runtime for building modern agentic applications. And I think you can really see the power in demos like this. It's not there. Where is Golem? Let me show you where Golem is. Golem is here on line 12. That's where Golem is. And the rest of this is just using AI SDK inside the context of this class. Everything else we get for free out of the Golem runtime that powers this. So I think Vercel's AI SDK and Golem are a match made in heaven. The AI SDK gives you intelligence, tool interaction, all that fun stuff, support of many models. And then Golem gives you that superpower, invincible agents that never forget and never repeat actions. And both are open source or free to use for any project you want. So go ahead and give them a try. If you like what you've seen today, then please slide into our Discord server and say hello. We love to learn about people who are using Golem and help them be successful. So just hop into our Discord and say hello to us there, and we can tell you about all the fun stuff that's coming up the pipeline in future Golem releases. Thank you, everyone, for attending this demo. It was great to have you here, this live stream. And I will see you all in probably 2 weeks with another live stream doing cool stuff in Golem. Daniel, thank you for all your help today. It was invaluable.